Hey all, welcome back to my channel. So in today's session we are going to see about part 2 of Verilog in one shot. Okay, so in yesterday's session we have already discussed about the major concepts in Verilog. We have discussed about the data types, and we have discussed about the modeling coding styles gate level modeling and data flow modeling. So in today's session we are going to see about behavioral modeling and some other major concepts in Verilog, right? So before going into the concept, if you are new to my channel, consider subscribing my channel and hit on the notification bell also. And also, if you come under any VLSI aspirants or enthusiasts who are interested to enter into front-end design and verification domain, please share this video to them so that it will be useful for to create their future in this VLSI domain, right? So coming to behavioral modeling. So we have already seen about how we can write the code in gate level and data flow. So when it comes to gate level, based on by using the logic gates like AND and OR gates, which are already inbuilt in the Verilog, like they are called as gate primitives. So by using those gate primitives, we will be writing our code in gate level modeling. So in gate level modeling, the most important thing is the structure of the design. So based on the structure of your design only, you can write the code in case of gate level modeling. So when it comes to data level modeling, based on how the data is flowing between the registers, okay, so how the data flow is between the registers, so based on this, taking this into consideration, we'll be writing the code in case of data flow modeling. Okay, now coming to behavioral modeling. So in the behavioral modeling, how are we going to write our code? Like based on how your design is behaving for your particular inputs. Okay, so based on the behavior of your circuit, you will be writing the code in case of behavioral modeling. And also the gate level modeling is considered as the lowest level of modeling in Verilog, because which level is already removed in case of in Verilog language. So mostly we'll prefer gate level as the lowest level of abstraction and modeling behavioral level modeling as the highest level of abstraction, because while we are designing for complex circuits, okay, we'll mostly opt for behavioral modeling than that of this data flow modeling and gate level modeling. So by in when we are taking it simply, what we do is when we are analyzing a combinational circuits, we will go for data flow modeling, and when we are analyzing the sequential circuits, we will be opting for this behavioral level modeling. Okay, simple in simple. That doesn't mean that combinational circuits can only be written in data flow modeling and the sequential circuits can only be written in behavioral modeling. But mostly when we opt for writing the coding styles, we use data flow modeling for combinational circuits, and we use this sequential circuits for behavioral level modeling. Okay, so as we all discussed that behavioral modeling, in behavior we will be writing the code based on the behavior of the circuits. Okay, so in this behavioral level modeling, it consists of some procedural statements. Okay, so which are used in order to control the simulation, right? So basically when it comes to behavioral modeling, we will be doing it with the help of procedural blocks. So we can say that behavioral modeling consists of some structured procedural blocks. Okay, so again, this structured procedural blocks in behavioral modeling is categorized into two parts. Like one is initial block and the second one is always block. So in behavioral modeling, these two blocks are very important. We should know everything about initial block and always block, because whatever code we are writing in case of behavioral modeling, like whatever we are writing in the RTL code or whatever we are writing in the test bench code, we will mostly use these two blocks, which is initial block and always block. So let us know some details about this initial and always block. Okay, now coming into initial block. So in this initial block, as the name itself says, it will be executed only once. Okay, when the simulation is being done, when the code is being run, it will be executed only once. this initial. So whatever code that you are writing within the initial block, that will be executed only once. And also this initial block is non-synthesizable block. That means it can't be used for RTL, like it can't be converted into hardware description like hardware. That is why mostly we'll use this initial block in test bench. Okay, and this initial, when we are writing the using this initial procedural block, okay, we'll be using the keyword called initial. And in initial, if you want to write a code which is more than one statement, like if your code consists of more than one statement, then you should use the keywords like begin and end. So within begin and end, you should be writing your entire code in the initial block. And also in Verilog code, in your Verilog code, you can have many number of initial blocks. Okay, there is no rule that you should only write one initial block within your particular code. Okay, you can write any number of initial blocks, and also while you are running the code, all these initial blocks will be running parallelly. That means everything will be started at zero simulation time. Okay, so if you are taking some 10 initial blocks, all these 10 initial blocks will be starting at zero time unit. Okay, in case of initial block. And also one thing you should avoid while you are writing this initial block is you shouldn't use nested initial block. That means you shouldn't use one initial block within another initial block. This should be avoided in case of initial block. Okay, and also you can use delays in the initial block. So this is about the basic idea of what is initial block. So when you're writing an initial block example, so this is how you will be writing. Okay, you can have any number of statements. If you have more than one number of statement, you will be using the begin and end. Okay, and when you are writing the initial block, if you are writing some three initial blocks here, all the three initial blocks will be starting at zero time step. Okay, so this is how, see here you are writing two initial blocks, so both of these initial blocks will be starting at zero time step. Okay, but based on the delays you are using, the time will be changing. Got my point? So this is about initial block. Now coming to always block. Okay, so it is similar to that of initial block in some cases, but differs in some other cases. Like if you see initial block, that will be executed only once, but this in a always block, this can be executed any number of times. Like if you want to execute it any number, some 10 number of times, it will be running for 10 number of times based on the condition you are giving. Okay, so that is important here, right? And also one more difference in case of initial and always block is synthesizable. So which is why we mostly use always block in case of RTL code, and we'll use initial block in case of test bench writing. When you are writing a test bench code, you'll be using the initial block, and when you are writing the RTL code, you will be mostly opting for always block. But this is not the rule, you do like that. Basically that is what I'm telling. Generally when you are generating some clocks, okay, in such cases when you want to repeat the execution for n number of times, you will be using this always block. Okay, just like initial procedural block, you will use the initial keyword. In this always procedural block, you will be using always keyword. And similarities, when it comes to similarities, both initial block and always block also, if you have and like multiple number of statements, you will be writing them within begin and end blocks. Okay, and similarly both in initial and always block also, you can write any number of initial blocks and you can write any number of always block. And same like initial block, if you are writing some three initial blocks, all the initial blocks will be running concurrently. Similarly in always block also, if you are writing for three always blocks, all the three always blocks will be running parallelly based on the delays that you are giving. Okay, these are the similarities and these are the differences between always and initial block. Okay, so, as I told you, when it comes to always block, it will be running n number of times. So, how to make it run for n number of times? Okay. So, basically, when will this always block will be executed? So, this always block will be executed when there is the sensitivity list. Okay. When there is any change in this particular sensitivity list, then only this always block will be activated. Okay. It will be represented with @ symbol. Okay, and whatever you're writing within this parenthesis, generally when you are going for always block, the syntax will be in this manner: always at the rate, okay, star. Basically if you see any code, it will be mentioned as star. Okay, only some cases you will be seeing like at the rate of posage of clock, at the rate of negage of reset. In that way you will be seeing. In most cases you will be seeing that as a star. Okay, so what you are writing within this arguments is called as sensitivity list. So based on this sensitivity list only, this always block will be activated. Okay, for example, if there is no sensitivity list, what happens? So if there is no sensitivity list, then the always block will be executed repeatedly and it will enter into the zero infinite loop, like it will be running forever. Okay, so until it enters into zero infinite loop, it will be running and your program will be hanged. So that is why mostly you will be using the sensitivity list. So what does the sensitivity list consist of? Nothing but conditions. Okay, some conditions in order to activate your particular always block. For example, always at the rate of posage of clock. If you are giving like that, now what happens? Okay, whenever there is posage of clock, then only this always block will be activated. If there is negage of clock, then this always block will not be activated. So that is the important of sensitivity list. Sensitivity list means it is the control for the always block, because always block will be executed for n number of times. So in order to control it, okay, in order to not to allow it to go into the infinite loop, we will be using this sensitivity list. Hope you got an idea on what is sensitivity list or how important it is in order to activate this when you are using the always block. Okay, so this is the thing. And the most important thing that you should consider, what is it? That here this you will be having a sensitivity list. Okay, so this is how the always block will be written. Like if you have only single statement, no need of begin and end, but you are having multiple statements, then you should be writing it within begin and end, always at the rate sensitivity list. Okay, so this is the small example in order to generate the clock. Okay, for example, while you are generating the clock, it is like it should always be until your program will be continued. Okay, the it should always generate a clock. Okay, here I am taking the clock with 5 time period, like my posage will be at 5 time units and my negage will be of 5 time units. So the total time period of my clock is of 10 time units. Okay, so this is about the always block. This is how you will be generating the clock. Okay, in the by using just the always block. Clear? Hope this is clear about this particular behavioral modeling blocks, procedural blocks like initial procedural block and always procedural block. Okay, now coming to procedural assignments. So what is this assignment? Before going into the procedural assignments, let us see what is Verilog assignment. So what is the meaning of assignment? Assignment is nothing but put some values into your particular variable. For example, I am telling that a equal to 5. Now what I am doing, I am assigning the value 5 to my variable a. Okay, this is called as assignment. Okay, and also in Verilog you are having some two kinds of assignments. Basically it is called three kinds of assignments. Okay, one is continuous assignment, second is procedural assignment, and the third one is procedural continuous assignment. Okay, now coming to what is this three assignments, like what is continuous, what is procedural, and what is procedural continuous assignment. So basically continuous assignment is nothing but the assignment that you see in the data flow modeling. Okay, in the data flow modeling, how the assignment takes place, like you will be assigning some, for example, by using a keyword assign. Okay, assign some c equal to a plus b, right? Like this is called as LHS equal to RHS, is it or not? So this is what the assignment is there in data flow modeling. So this type of assignment is called continuous assignment. Okay, now if the for this same thing, if you are doing like without using the assign keyword, if you are giving it like less than or equal to a plus b, this is called procedural assignment. Okay, so this is the procedural assignment and this is the continuous assignment. Clear? So again, in procedural assignments also, basically you are having two kinds of assignments, like one is blocking assignment and another one is non-blocking assignment. Okay, so basically what happens, what is the difference between the continuous assignment and procedural assignment? For example, if this is the continuous assignment, what happens means, as soon as the operation like a plus b is completed in the RHS, that means as soon as the RHS expression is completed, then immediately the value of a plus b is assigned to c. Okay, until and unless it is not assigned to C, it won't go to the next step. So that is what continuous assignment means. Again, in procedural assignment, okay, you are having blocking and non-blocking assignments. So in both of these assignments also you will be having the difference. So let us see that what is the blocking assignment and what is the non-blocking assignment. Basically, if you see, continuous assignment and blocking assignment are same. Okay, so blocking assignment is given with a keyword like equal to. Okay, and non-blocking assignment is mentioned with this symbol. Okay, so this is the symbol for blocking assignment, this is the symbol for non-blocking assignment. So what will be the difference between these two statements? Like what is the exact difference between blocking statements and non-blocking statements? Okay, let us see with an example here. See, this is how basically now if you see this particular symbol, you have seen it somewhere. If you see, this is a relational operator also. This symbol is used as less than or equal to relational operator, and this symbol is also used as an arrow for non-blocking assignments. So how can the system compile the see the difference between if it is a relational operator or if it is a non-blocking assignment? So basically, when you are using it in between the expression, then it is interpreted as a relational operator. Okay, if you are using it for assignment, like if you are using it for assigning some value, then it is interpreted as non-blocking operator. Okay, hope you got the difference. Why? Because in interviews it may ask like what is the difference between this as a relational operator and as a non-blocking operator. So basically, when you use it in between the expression, then it is a relational operator, and when you use it to assign some value to a variable, then it is a non-blocking operator. Okay, now let us see what is the difference between the blocking assignments and non-blocking assignments in one shot. Like with one simple example and one simple sentence, I will tell you the difference between the blocking and non-blocking assignments. So let us see this particular example here. Okay, x equal to a less a or b. Okay, y equal to a x or b x or c. Z equal to b and negation of c. So I am writing this as a non-blocking assignment. For example, if you are using it a blocking assignment, then what happens means, okay, after the completion of A or B operation, first let us consider it as a blocking statement. Okay, now what happens after the completion of A or B, the value is assigned to X. Okay, after the value is assigned to X, then the operation of AX or BX or C happens. Okay, now what happens after the completion of AX or BX or C, the value is assigned to Y, and then after assigning it to Y only, that means after completion of assigning RHs to LHs, then only the second statement starts. In the second statement, after assigning the value from RHs to LHs, then the third statement starts executing. That means B and negation of C operation takes place after completion of this particular variable. Okay, now what happens? When will this be executed? Okay, when after execution of this particular variable, then it is assigned to LHS, then only it will be coming to the next statement. So what is it happening here in case of blocking statements? Until the execution of one statement, the remaining statements are being blocked. Okay, so because of this reason, it may give a point of raising to raise around condition. Okay, which is a big default in case of blocking statements, right? So in order to avoid this race around condition and everything, we have opted for non-blocking assignment. So the same thing, when you come for non-blocking assignment, what happens means, first all the RHS expressions are being executed without assigning any value to LHS values. Like if you see here, ARB is executed and then it won't be assigned to X, but it will be executed. Similarly, AX or BX or C is executed. Next, B and negation of C is executed. So all the RHS expressions are executed, but the assignment takes at the end of the last step. Like if you see here, after executing B and negation of C, and after confirming that there are no more statements behind this, then only the values will be assigned to X, Y, and Z concurrently. So this is what the non-blocking assignment does. Okay, hope you got an idea on what is the difference between blocking and non-blocking assignments. So why? What if you are using a non, as I told you, what if you are using a no blocking statement, and what is the race around condition, or what are the advantages in case of using non-blocking statements? Okay, when you have certain conditions, let me put a certain condition for you, okay, before you, so that you can understand clearly what is the difference. Why should we go for non-blocking statements even though we are having the blocking statements? Okay, now let us see this some example here. Here I am assigning A value as 1 and B value as 0. Okay, here I am writing two always blocks parallelly. Now, if you know, as we have discussed before, if you can have any number of always blocks within your code, and all these always blocks will be running concurrently. So, if you see here, both these always blocks will be running concurrently. Now, what happens? Since if you are using a blocking statements until the execution of the, okay, now what happens? Either this or this will be running at zero time, that at starting time. Okay, at zero time units, both will be running parallelly, but the execution, the compiler will may execute the first statement first or the second statement. Now what happens? For example, let us consider if this passage is taken as the first passage of clock. Now what happens? Here you will be having every passage of clock. Okay, so at first passage of clock, if you are thinking that this always block is activated, now what happens? What is there in B, that is assigned to A. Now what will be the value of A? A will be 1. Okay, now after this thing, the second thing will be starting to execute. Now what happens? What is the value of A here? Actually the value of A is 1 here, and the value of B is 0. Okay, now if you see here, A is 1, okay, and B is also 1. Okay, so what is happening actually when you want to flip these values? Like I want, okay, I am writing a code in order to flip the values as A equal to 0 and B equal to 1, from A equal to 1 and B equal to 0. But what is happening here? Both are getting the values as 1. Okay, for example, if you consider this is activated first, now what happens? Here A equal to, what is it? A equal to 1, so that is assigned to B. So now what happens? A is also equal to 1. So similarly, in this way, based on the values, only one value, here no flipping is done, but only the value is getting, either both are ones or both are zeros. Now if you are using the non-blocking statements for the same statement, what happens? Okay, here if you see, A is non-blocking statement assignment to B is non-blocking statement assigned to A. Since you all know that before assigning anything, only first the values will be assigned to this RHS. Okay, now what happens? B value will be 0 is assigned here, but it is not assigned to A. Okay, similarly A value is 1 is placed here, but it is not assigned to A. So after completion of everything into RHS, then the LHS takes place. So now what is the value of A? 0. What is the value of B? 1. If you see here, which is the flip-flop of this particular answers. This is what I needed. So in such conditions, like when you want to assign some values or when you want to flip some values, okay, in such conditions there may occur a race around condition, which can be avoided by using this non-blocking statement. Okay, hope you got an idea on what is blocking and non-blocking statements. Okay, so let us see the some internal procedure, like what is happening if we are using the blocking and if you are using the non-blocking. Why is this happening? Like if you see here, why the same value is attaining in case of blocking statement, and why the flip-flopping is being done in case of non-blocking statement. Let us see here. Here I am taking like three values. If you see here, q1 equal to in, the same thing here, the logic is same. If you see here, okay, for both things the logic is same. What I am doing, I am using a blocking statement in one thing and non-blocking statements in another program. Like if you are using the blocking statement, what happens? For example, let us consider the values like the basic value, previous values. Okay, some in equal to 1 and q1 equal to 0 and q2 equal to 1. Let us consider these are the three values. Now what happens? What is there in in is assigned to q1 immediately. Okay, so what is there in i1? 1, that is assigned to q, so q1 is 1. So after execution of this statement, then only that comes to the second statement. So what is the q1 value? It is 1, that is assigned to q2. What is q2 value? 1, that is assigned to 1. So what is actually the output? Output is nothing but the input. What is there in input? That is assigned to output. Now what are these registers? There is no intermediate registers here. They are just a passing. They are just a points in order to pass the values. They doesn't contain any value in such statements. Okay, now if you are seeing the same thing here, what is in here? In is actually 1. Okay, in is 1, but that is not assigned to q1. Okay, first you already know that in non-blocking statements all the left hand, all the right hand side execution will be taking place first. So what is q1? 0. What is q2? 1. So after having initializing all the values on the RHS, then the assignment takes place. Now what happens? q1 1 equal to 2, q2 will be equal to 0. Okay, and out will be equal to q1. So in this way, the serial execution, like serial input, serial output, here no serial input, no serial output, only what is there in input that will be there in the, what is there in input that is there in the output. That's it. There are no serial cases in case of this blocking statements, but in case of this, whatever that is there in input, that is first going to q1. What is that is there in q1, that is going to q2, and then from q2 it is going to output. So in this way, actual so as serial input serial output stage is working out in case of non-blocking statements, which is an utter flop in case of blocking statements. Hope you got an idea. Like this is how, like if you are using a non-blocking statement, three flip-flops are being created, but when you are using a blocking statement, only one thing, the intermediate connections are just, if you see here, x and y doesn't contain any value in case of this particular non-blocking, sorry, blocking statements. Okay, hope you got an idea. Like this, if you see, before we have explained, see, three D flip-flops are created. Like here you are having three things, so three flip-flops are being created. But here in non-blocking statements, even though you are having three flip-flops, only one flip-flop is being created, which is a big failure in case of blocking statements, which is why when you want to assign, like when you want to design some circuits which are based on like serial input and serial output, or in such way, so when you are designing such things, you mostly prefer for non-blocking statements instead of blocking statements. So these are certain differences for blocking and non-blocking statements. Okay, you can pause this video and you can study the differences. I have already explained all the differences, and also in clear explanation, like I have given some 2 or 3 explanations for blocking and non-blocking statements in detail. Okay, in my Verilog Hdl tutorial videos. Okay, I link the Verilog Hdl tutorial in my playlist in my particular description box. You can go there and check out all the videos on Verilog if you are a fresher and if you are not at all familiar with Verilog. Okay, after seeing this video, try to check on in detail about every concept in my particular Verilog Hdl tutorial. Right? So this is about the blocking and non-blocking statements. And just like in data flow modeling, you will be using delays. In this behavioral modeling also, you will be using delays. Okay, in behavioral modeling, you are having like two kinds of delays. One is delayed assignment and another is intra-assignment delay. So delayed assignment means at the starting itself, like at the during the starting of the expression itself, you will be giving the delay, like the hash delta t. Okay, when it comes to intra assignment delay, okay, with expression only, with you will be within the expression, you will be in intra assignment, that means before assigning only you are giving the delay. But here delayed. That means after assigning the value to the variable, then you are giving the delay. Okay, so this is about the delayed assignment and intra assignment delay. Like, what is the difference between the delayed assignment and intra delay assignment? Okay, just simply I'll give you a small example for you. Here, if you see this is the delayed assignment and this is intra assignment delay. Like, in case of delay assignment, what happens here? If you see the expression C equal to A or B, now what happens? A or B will be getting evaluated at 20 nanoseconds, and then it will be assigned immediately to C. Okay, in case of intra assignment delay. Whereas delayed assignment, what happens? Sorry, in case of delayed assignment, in case of intra assignment, what happens here? The execution is done, okay, gets evaluated at time before, and that means here, since it is having 20 nanoseconds, so at that particular time only the execution is happening, but the assignment takes 50 time units of delay. That means 50 plus 20 70 time units of delay for assigning some value. Okay, that is the difference between intra assignment delay and delayed assignment. If you want to know clearly about it, I have already explained about that in the particular video in the Verilog Hdl. You can go there, check it out. But this is the major difference between delayed assignment and intra assignment delay. Okay, now, as we already discussed in the data flow modeling, like in data flow modeling, you will be using the operators in order to create the expressions, and you will be writing the code. Similarly, in case of behavioral modeling, okay, you will be using conditional statements, and also you will be using some other things. Like, first thing, you will be using the conditional statements. So in conditional statements, you are having two kinds of conditional statements, and by using the loops, okay, by using conditional statements and loops only, you will be writing the behavioral level modeling, right? So in behavioral modeling, if you see, you will be using two conditional statements like if else and case statement. Okay, you can just check the syntax of this is if else if. Okay, I have already explained this about conditional statements also in my Verilog Hdl tutorial. If you are interested in knowing about the statements like conditional assignments, case statements and everything, you can go check that video. And if you have any doubts, you can ping me in any of my social media handles. I'll be available at any point of time if you are having any doubt, right, regarding subject. So this is about the case statement. So this is how you will be writing the case statement. Okay, now coming to, so when you are using sequential circuit and when you want to write a case statement, so this is the program for creating the JK flip flop. Okay, the RTL code for JK flip flop, right? If you have, you can pause this video and check out this particular program code on JK flip flop, and if you are having any doubt, you can ping me, right? Then you will be in Verilog, along with conditional statements, you will be using the loops like for loop, while loop, forever loop, repeat loop. So these are the most frequently used loops in case of Verilog. Okay, for loop you already know, this is the syntax for loop. Okay, right? Now coming to while loop, so this is how you will be writing the while loop expression, and this is the syntax for that particular thing. And then coming to forever loop, like if you want to execute some particular code or some particular statement for n number of times, okay, for they will call it as forever, but if you want to repeat it for some many number of times, you will be going for this forever loop. That means it will be running forever until you give some constructions like dollar finish or anything. Okay, until you give the system task like dollar finish, it will be running for foreverly. Okay, so this is how. See, if you see here, I have given like hash finish dollar finish hash $10 finish. That means until I am giving at 10 time units. So if you here, if you see from 0 to 9, the iterating statement is being printed for n number of times until I have given the dollar finish. That means in order to break the forever loop, you have to use the system task dollar finish. Okay, so this is about it. And then repeat loop, like if you see in forever loop, it will, if you don't give any particular dollar finish, it will be running forever. But in case of repeat loop, it is not like that. Repeat means you need to give it a condition like you should repeat it for five number of times, for 10 number of times. So in this way, you should be mentioning the number in order to make that loop to repeat. Okay, so that is the main difference between forever loop and repeat loop. Right, now coming to the one of the major concepts in Verilog, which is Verilog tasks and functions. Okay, tasks and functions have some similarities, have some dissimilarities also. So anything, either it is a task or a function, it is nothing but when you want to use a certain group of statements, like certain piece of code at for 4 or 5 times in your particular code, then you can write that piece of code within the function and end function, and then it becomes a function. So you can call this function with that particular name at any point of your time or at any point of your code. Okay, so that is about Verilog functions and tasks. Hope you got an idea on what is Verilog functions and tasks. Okay, simply we call this task or function as a subroutine. Okay, so subroutine is nothing but it is a piece of code where you will be writing at some point of time, and when you want to call it, you can call it with name at any part of your code. Okay, so this is how you will be writing the function in case of Verilog. This is syntax like function. Okay, for you, if you are not giving any automatic keyword, it is by nature static in nature, like function, return type, name, and then arguments. Okay, arguments means nothing but the inputs and outputs basically. And then if you are having many number of statements, you will be writing within begin and end. Okay, and then within this you will be writing the function definition, which is nothing but the piece of code which you want to repeat for n number of times. Okay, and then end function. So this is how you will be writing the function. Like, the main important thing you should consider is first you should declare the function in order to call it. Like, if you are calling it and if you didn't declare the function, then the compiler know where you have you written that function and where are you calling it. So that is why in order to call the function, you have to first declare it. So this is how you will be declaring the function, like function, return type, name, arguments. And this is called the definition is nothing but the logic that you are using. Okay, the piece of code that you are writing. So when it comes to defining the functions, you can do it in two ways. Like, you can give the inputs list, like input and output ports within the arguments itself, or you can just declare it within the function. Like, inside the function you can declare the list and you can write that particular code or expression. Okay, so this is how, see, if you see here, you can either give this input a comma b here itself by using the arguments in this way, or you can explain it within the function. Okay, and then you will be writing the actual code, which is this particular line, sum equal to a plus b. So this is my particular function which I want to call it. So see, this is the example. See, the same function here, a and b. Okay, sum equal to a plus b. So this is the function return value. Okay, if you see here, when it comes to the calling function, like, this is the part of code that you have written at some place of your program, and if you want to call it at some place of your time, how can you do it? Like, if you see here, a equal to 4 and b equal to 5, here actually the given thing is a equal to, here you have just written a equal a and b, and you are writing the function here. Now when you want to call it, you should call it with the name of that function. Here the function name is sum, so I am just calling sum equal to a comma b. Now what happens? A equal to 4 will be assigned to a and b equal to 5 will be assigned to b. Okay, so this is how you will be calling a function. Okay, so this is how you will be writing the function, like, this is my function. Okay, this is how you will be declaring the function, and then this is how you will be calling the function, like, this is my function addition. Okay, and you will be calling it like this. Clear? Right, hope it is helpful for you. Now coming to Verilog function rules. So while you are defining function, you should follow certain rules before defining any function. Okay, which is considered as once as disadvantage and sometimes as disadvantages while you are using the functions. So the first thing is, Verilog functions can have one or more input arguments. Like, you can have one or more input arguments in case of Verilog functions, and functions can only return one value. Like when you are writing the functions, it can only return one value at a time. Okay, and also one important thing while you are writing functions is functions should not use any time consuming constructs. Like you shouldn't use at the rate of passage of clock or delays, or you shouldn't use non-blocking statements in case of functions, because all this will be representing some time delays, which is not possible in case of functions. Okay, so when you are using any time delay constraints, it is better to use task instead of function. Okay, and when you want to use any non-blocking assignments also, you can't use function, so that is why you can use task there. Okay, and one more important thing is we can't call other function from within, sorry, we can't call task from within function. That means by using a function you can't call task, but by using a task you can call function. Why is that? Because task can have non-blocking, or task doesn't have any rules. Like only these rules are limited to functions itself. When it comes to task, you can write it in any way. Like it doesn't no need to consist of any inputs, or it can have any number of inputs, or it doesn't have any inputs, or it can return any number of outputs at a time, or it can have many, like it can have any passage of clock or any delays. It can use any non-blocking assignments. So that is why when you want to write a liberal code without any following any of these rules, you write it as a task. And when you want to write a code which is below all these function rules, then you can be opting for function instead of task. Okay, so this is the particular functional rules about the functions. Okay, when now coming to task, as we already discussed in the before thing itself, like when you want to use any delays or any passage of clocks, and when we can use both blocking and non-blocking statements. So mostly when you are using any time consuming constructs, you can go for task instead of functions. Okay, and can as I told you, Verilog task can have any number of inputs, and it can generate any number of output also. Okay, so these features means tasks are best to implement. That is why since it doesn't have any rules and it is easy to write, mostly we go for tasks in any program instead of writing it by a function. Okay, so this is how you'll be. So if you see here, without any inputs also you can write a task. Okay, task sum, right? So this is how you will be writing your task. Clear? So these are some of the advantages, sorry, these are the some of the difference between task and function. Just pause this video and check this particular table so that you will get the difference between what is task and function, which is very important in case of Verilog. Okay, because if you know about this task and function only, when you take a step forward in your design and verification domain, like if you want to learn some system Verilog courses also, there also here task and functions are very important. So that is why you just see the differences between task and function, which is the most frequently asked interview question also. Like they will be asking at least 2 or 3 differences between tasks and functions. So that is why try to remember these particular differences between task and functions. And when you are reading it, if you are having any doubt, you can ping me in the comment box. Okay, and now coming to the compiler directives, which is also a major thing in case of Verilog. Like compiler directives are nothing but they are which are based on like you will be seeing these compiler directives in any programming language. Basically they are based on compilers. Okay, so they will tell how the compiler will compile the code. Like basically they will tell you how the compiler is compiling the code. And in Verilog you are having various compiler directives. Okay, if you see, when you are defining a compiler directive or when you are writing a compiler directive, it will be given by a backslash symbol. Like tick will be called as tick. Okay, tick define, tick include, tick if def, tick if and def, tick else if, tick else, tick time scale, tick and def, tick reset all, tick default net type. So from the name itself you can grab the knowledge on what is the work that they will do. Okay, so coming to tick define, when you want to define, so basically it is similar to that of parameter, but in parameter there is a chance to overwrite it during the runtime. Okay, so similarly tick define is nothing but it will be defining something. You can say that when you want to define a particular macro or constant or particular variable. Okay, so basically you will do that by using the tick define symbol. Okay, and when you want to particularly undefine it, you will be using the tick undefined compiler directive. Okay, so tick if define, tick define is to define the particular variable or particular macro, and tick undefine is to undefine that particular macro what you have defined already. Okay, in order to use the undef, first you should use def. Okay, until and unless you don't define it, you can't undefine it. I hope you got the this small logic. Okay, so what is the tick def and tick undef? And then coming to tick include. So from the name itself, if you can say, if you want to include any other files within your particular files, then you can use this tick include. Okay, similarly tickfdef, tickifndef. Tickfdef is used in order to check whether you have defined that particular constant or particular macro. Okay, when you are writing the code and at some part of your code, if you want to check whether you have actually defined that particular constant or that particular macro, you will be using the if def. Okay, and here then if ndef means if not defined. Okay, if you don't define that particular keyword or particular constant, and if you want to include something, like if you see here, if you have defined something, you need certain work to be done. If you don't define it, you need certain another work to be done. So in such cases, that means if you are defining that particular constant, that some particular piece of code is to be executed, and if you are not defining that, other particular piece of code need to be executed. It is very similar to that of if else. Okay, so basically in such conditions you will be using if def and if and def. Similar to this also, like tick else if. So basically it is very similar to conditional statements like if else if. So all this. Okay, you already know the conditional statements. Similarly, similar to that of conditional statements only, you will be using this compiler directives like tick if def, tick if and def, tick else if and tick else. Okay, now coming to time scale. Okay, while you are coding and while executing the code or running the code in the EDA playground or in any simulator, okay, you will be observing at the side window, you will be observing the time scale units. Okay, like 1 nanosecond by 1 picosecond. So basically it is nothing but, okay, how where you will be generating the clock, right? So while you are generating the clock and while the simulator is being running, so at what period, like how your simulator is being run. Okay, so basically that is given by, like Verilog simulation depends on how time is defined, because the simulator needs to know at what time the simulation needs to, like when you are giving the delay, okay, it should know at how it should use the delay, like it should be using it in the format of 1 nanosecond by 1 picosecond and 10 microseconds by 100 nanoseconds. So in order to know this, you should be using this tick time scale format. Okay, you should know about this tick time scale compiler directive. So basically when it comes to the tick time scale units, it is time unit by time precision. Okay, time unit is nothing but it is the measurement of delays and simulation time. Okay, in order to measure the delays and simulation time, you will be using this time unit. Time precision is nothing but how delay values are rounded off. Like when you are giving the precision time, it will be rounding off your delays. Okay, so I have already made the separate video of that tick time scale directives. Okay, you can check that video, right? So that is about the tick time scale. Basically tick time scale compiler directive is in order to make you understand how the delays are being taken, how the simulator is being run. Okay, so basically this is about the tick time scale. So see, this is the example. Okay, if you are giving basically 1 nanosecond by 1 nanosecond, and when you are being rounded off, like if you are giving 0.45 as the delay, okay, based on this time scale properties, like based on the units of this time scale that you are being giving only, this particular values will be rounded off to the values like 0 0 1 2. So this value is rounded off to 1, this value is rounded off to, okay, 2 and this is rounded off to 0. So basically this is how the round value will be taking place. Okay, so this is about time scale. And apart from this time scales, okay, you are having some time functions in order to know the simulation time. Okay, we have already discussed it in the previous, like when we are discussing about data types, we have already discussed it, like dollar time and dollar real time. In order to know the simulation time of the particular, at what particular simulation time your statement is being simulated, so basically you will be using this particular time function called dollar time. And in order to know the floating value, like in order to know the points value of the time, you will be using this real time. Okay, so these are the basic time functions in the Verilog. Now coming to randomization function. So randomization, so you will be using mostly about this randomization, you will be learning mostly about this randomization when you are learning about system Verilog concepts. But Verilog also can provide the random values, okay, but not as efficient as you are seeing it in system Verilog. So in order to provide the random values in Verilog, you will be using these three commands, like $random. It will be generating, it is used to generate a random bits of 32-bit signed number. And you want to generate the 32-bit unsigned number, then you will be using the $u random keyword. Okay, and when you want to generate the values, like when you want to generate the values between 1 to 100, that means you are giving the range. And now what happens, within these 1 to 100 values only it will generate the random values. So when you are giving it within the range, then you will be going for u random range. Okay, clear? So these are some of the basic randomization functions in Verilog. Now coming to some system tasks and functions. Okay, so these are the basic system tasks or system functions, whatever you call it, whether system task or system functions. Basically, in order to display the values, you will be using these four tasks: dollar display, dollar monitor, dollar strobe, and dollar write. Okay, so you will be seeing these differences. I have made a full length video on all the system tasks in detail. You can go there and check it out. So when you are using these tasks, you will be using the dollar symbol before. So these are called as system tasks. Okay, dollar display. So basically they are used just like in C you are having the printf in order to print values. Okay, in order to print values on the log file, you will be using four kinds. But in C you will be having only printf, but in Verilog you are having four kinds. So every kind have its unique features, like dollar display, dollar monitor, dollar strobe, and dollar write. Okay, and here basically they have some unique features. You will be seeing them in the full length video. If you want to check that out, you can check it. So basically dollar display is used to display immediately. Okay, so in Verilog you are having like four regions. So every of these four tasks will be activated in four different regions. Okay, you will be seeing that in the next slide. Basically, so Verilog is having four regions. What are those? Active, inactive, non-blocking, and postponed or monitored region. Both we can call it as, mostly we'll call it as postponed region. Okay, so active region, inactive region, non-blocking assignment, monitor. So whatever code that you are writing in your RTL and in your test bench, mostly in Verilog. Okay, when you are using Verilog in order to write your code, every part of your code will be executed only in these four regions. Either it may be activated in active region or inactive region or non-blocking assignment or postponed region. But every statement or every logic that you are writing within your code will be activated only among these four regions. Okay, but in system Verilog, if you see, you are having 11 such regions in order to execute your code. Okay, that is advantage in system Verilog, because mostly we'll be designing for complex circuits. We need more regions when it comes to executing that particular code. Okay, that is why mostly we prefer system Verilog for verification than compared to that of Verilog. That is one important thing you should consider. Okay, but as for Verilog, you are having four regions. Okay, now talking about these four regions, firstly active region. Active region means basically which is used to like display the current events. Basically, as I told you, every code, like if your code consists of some display statements or some monitor statements or some data flow modeling logic, some behavior level modeling. Again, in data flow you are having some assign statements. Again, in procedural you will be having some blocking statements, non-blocking statements. Is it or not? So your code consists of all these things. So when you consider all these things, every part of your code, like blocking statement will be executed in one part of region, non-blocking statements will be executed in another part of region, all the display statements will be executed in one part, all the monitor statements will be executed in one path. So at which point are these being executed? Let us see. Now if you see, in case of region, active region, what are the things that will be activative? All the gate level modeling Verilog primitives, like Verilog, whatever you will be writing gate level modeling code, everything will be activated, evaluated in active region. Similarly, all the right hand side of non-blocking statements, like if you see the non-blocking statement, it is like this. Is it or not? So everything that is written inside expression of RHS will be evaluated in active region itself. And also when you are taking any assign statements, continuous assignments of all modules, similarly blocking assignments, similarly dollar display, dollar finish commands, so all these will be executed and evaluated in case of active region itself. So when it comes to evaluation, all the gate primitives and all the RHS of this particular things, like all the RHS of non-blocking assignments will be done in case of active region. Similarly, when it comes to execution, when you are not using a non-blocking statement, when you are using a blocking statement, then the working, like execution of RHS and assignment of LHS is also done in the active region. And also when it comes to system task, dollar finish and dollar display will be executed in this particular active region. Clear? Now coming to inactive region. So basically, when you don't give any delay and when you are giving #0 delay, okay, there is some difference between this. Actually, without giving any delay and #0 delay are both same. But when it comes to execution, if you are not giving any delay, that will be executed in active region. If you are giving a #0, then that statement is executed in the inactive region. Okay, so that is the main difference, because when you are writing some code in system Verilog, basically in the previous sessions when we are discussing in system Verilog, I have given you some questions. So in my LinkedIn, you can go follow in my LinkedIn ID. There I have given some questions on fork and join. Okay, where I have given some codes like #0. Okay, I have given some statement like dollar display with #0 and dollar display without #0. So when you go there and check it out, you will go, when you go there and execute, you will know the difference between #0 and without giving any zero. Okay, so basically when you are giving #0, because this is the most frequently asked interview questions, like many questions will, when any interviewer want to trick you, they will be giving such questions like what is the difference between without dollar display and #0 dollar display. So what will be the difference? Actually, this is executed in active region, this is executed in inactive region. Okay, there may be no or not much difference, but this is the major difference. Okay, like they will be executed in active and this will be executed in inactive region. Right, so this is the about inactive region. Now coming to non-blocking assignment region. NBA means non-blocking assignment. You will know from the name itself, you could know that whatever you are assigning, okay, like non-blocking assignments assignment, like if you see non-blocking assignments, LHS is equal to RHS, is it or not? So this is evaluated in active region. Now the assignments takes place in the non-blocking assignment region. Okay, that means the assignment from RHS to LHS is taken at non-blocking region. Now coming to postpone region. So the system task like dollar monitor on dollar stop will be activated in this, executed in this particular postpone region. Right, so this is about the regions in Verilog. Right, clear? So along with this, you are having some system controlling system tasks. Like these are basic system tasks, okay, in order to display the thing. And when you want to control the simulation, you will be using some similar tasks like $stop, $finish, $reset. Okay, $finish means in order to terminate the simulation. Okay, $stop means in order to suspend the simulation. That means even though there is code, if you are using $stop, it won't run the remaining simulation and it will be getting out of the particular thing. And $finish means it will be after completing all the execution, it will be terminating the simulation by itself. $reset, okay, in order to reset the simulation back to zero time. Okay, so these are particular topics in Verilog. So hope I have covered all the topics in Verilog, right? Hope it is helpful for you. So this is the part 2 of Verilog, right? So since in order to make you understand about Verilog at one shot, all topics I have made it into two parts. Hope I have covered every topic. If I did miss any topic, you can comment me in the comment box. And also, if you are a VLSI aspirant and you are dreaming to aim your future in this DV course, like design and verification, you need to learn certain courses like Verilog system, Verilog, and UVM. Okay, so if you come under any VLSI aspirant, and if you yourself are a VLSI aspirant, please do consider subscribing my channel and hit on the notification bell, so that it is kind of motivation for me to give more such content on these courses for free of cost. Okay, so that is all for today. Thank you all.